So we're going to take notes on day 7 and day 8. Both of them are graphing. Day 7, which we're about to start, is graphing inequalities. Some of them will be linear. They're going to be lines. Some of them are not lines. They're nonlinear. The ones that are nonlinear are going to require you to dig a little bit deep down in your brain and see if you can remember some of these graphs. First thing I will tell you, or one thing I will tell you, you see this homework assignment at the top? That's not what you're going to be doing. Instead, you're going to be doing a worksheet. So just know that your homework is a worksheet. Okay, so let's jump right in. Starting with some vocabulary, and then we're going to jump into some examples. The solution set of an inequality in two variables is the set of all ordered pairs that satisfy the inequality. So that's what we're going to be looking for right now, is all the ordered pairs that satisfy the inequality. We specifically are going to be looking at the graph. So let's just jump right in. You all have done this before. So if we look at example 1a, first thing I want us to recognize is how we know that this is a line. A line has a single x and a single y. It's not going to have x squared or y squared in it. It's not going to have any exponents. So single x, single y is going to be a line. So we know right away when we graph this, it's going to be a line. But what's really important is for us to pay attention to this inequality. So we're going to start by graphing the line, then we'll deal with the inequality. This is in standard form. Do not solve for y. Do not solve for y. That is extra work. If you get y alone, it takes too much work, A, and B, you're probably going to do it wrong. So instead, what we've done in the past, when it's standard form, is we've made an XY table. Okay, so we're looking for 2 points. The 2 points that are easiest to find are the intercepts. So plug in a 0 for x, solve for y. Plug in a 0 for y, solve for x. Okay, I'm going to plug in a 0 for x. I get 2 times 0 minus 3y equals 6. Ignore the inequality. Just treat it like an equal sign. So that is 0. If I divide by negative 3, I get y to be negative 2. So that is the first point. Then I'm going to plug in a 0 for y. So I get 2x minus 3 times 0 equals 6. 3 times 0, though, is just 0. So when I divide by 2, I get x equals 3. The biggest issue I see here is that students find those points correctly, but they graph them wrong. So we've got to make sure we graph them right. This first point, 0, negative 2. 0, negative 2 is right there. Second point, 3, 0 is right here. Before we connect those dots, does anybody remember with that inequality what it means when we draw this line in? Jack?
It's like shade. It's like test point.
We do have to shade. What else does it mean? It's dotted. That's what I was looking for. Less than or greater than with no equal sign is going to be a dotted line. So write this down. When there is an equal sign, it's going to be a solid line. So that's the first thing you always have to consider. So for us, there's our dotted line. And then like Jack said, we have to figure out our shading. Bless you. How do you do that? You're going to pick a test point. Pick one that's convenient. The most convenient point here is the origin, 0, 0. You cannot pick a point on the line. Has to be a point that's not on the line. So what I'm going to do is I'm going to plug that point back into the original inequality. So I get 2 times 0 minus 3 times 0 is less than 6. So 0 minus 0 is less than 6. That's true. So we will shade towards 0, 0, or on the side where 0, 0 is.
If it was false.
Then you're going to shade on the side that does not have 0, 0. So that's the first one. Questions before we look at another example? Okay, so let's look at B then. First thing I want us to recognize is how do we know it's a line? Single x, single y. Single x, single y, this is going to be a line. This is in a different form. You're not going to make a table here. This is slope-intercept form. 7 is our y-intercept. -3 is our slope. So I'm going to do the y-intercept first. I go up to 7 and put a point. If I have a slope of -3, is my line going to be rising or falling? Falling. Okay, so to get another point, I can go up 3 and over 1. I can go down 3 and over 1. And just do it a few times till you get yourself a few different points. Again, negative slope, the line should be falling. In this case, solid or dashed? Solid. Equal sign, there's going to be a solid line. To figure out our shading, we are going to pick a point that is not on the line. So again, you cannot pick a point that is on the line. In this case, I'm going to pick 0, 0 again. So that means 0 goes in for x and 0 goes in for y. So I get 0 is greater than or equal to -3 times 0 plus 7. So 0 is greater than or equal to 0 plus 7. True or false? False. So we do not shade on the side with 0, 0. We shade on the other side of the line. Does this seem familiar to us? It should. Okay, questions before we now look at graphs that are not linear? Okay, I'm going to need you to dig deep for these next few. Example 2a has an x squared, hence this is not going to be a line. Any memories of what this is as a graph? What shape it is? I told you it's not a line. It's a parabola. It's a parabola. Okay, with a parabola, we're going to have to be able to find the vertex. I'm going to just tell you the way to find the x value is -b over 2a. So the number in front of x squared is a, the number in front of x is b, and the other number is c. Okay, so our -b is -2 over 2 times a. -2 divided by 2 is -1. So our vertex is going to be at the point -1 comma something. How do I figure out what that y value is? Plug it in. Plug in -1. Be careful here. We get -1 squared plus 2 times -1 minus 3. So this becomes 1 minus 2 minus 3. So 1 subtract 2 is -1. -1 minus 3 is -4. So that's our vertex, -1 comma -4. Okay, so if we graph that, -1 comma -4. Before we find another point, what do we know about our parabola? What's going to be true about it? It's going to open up. Jaden, how do you know it opens up? Because the x squared is positive. We need at least 2 other points. So we are going to plug in some x values. What by far is going to be the easiest x value to plug in? 0. Yeah, don't pick a hard one, pick an easy one. X equals 0. That's going to give us 0 squared plus 2 times 0 minus 3. So that is the point 0, comma, negative 3. So this is right here. At this point, we don't even have to plug any more in. I don't know if you remember this, but a parabola is symmetric. It has this line that goes through the middle. It's called the axis of symmetry. So there are going to be mirror points on either side of the parabola. So what I mean is, this point right here, there is a mirror point on the other side, right here. Because of the equal sign in my inequality, I know that this parabola is going to be solid. So there's my parabola. If you wanted to plug in a few more values, you certainly could, but you don't need to. We still need to figure out the shading. So 0, 0 is not on the line, so it's okay for me to plug in. And again, you're plugging it into the inequality. We get 0 is less than or equal to 0 squared plus 2 times 0 minus 3. So in this case, 0 is less than or equal to negative 3. That is false. So I do not want to shade where 0, 0 is. 0, 0 is the inside of the parabola, so I don't want to shade that. I want to shade everything outside of the parabola. I want to see this work for plugging in a point on your homework. If you do not show that work, I will not give you full credit. Okay, questions before we look at the next one? Okay. In B, has an x squared and a y squared. Anybody know what this graph is going to be? Jaden?
I go DJ.
It will not, but thank you. It's not a V, it's not a parabola. We got no ideas? This is a circle. Circle, so I guess we need to review the equation for a circle. Write this down. We get x minus h. Ooh. Okay, x minus h squared plus y minus k squared equals r squared. So this h and k is the center of the circle, and r squared is the radius. So for our equation, we are given the center of the circle and a radius of the circle. Okay, the center is these two numbers right here. What is really important to remember is you have to flip the signs. So our center is actually -1, 2. Center, you always flip the signs. This 9 is our radius squared, so our radius is 3. So we're going to start with graphing our center, -1, 2. So that's right there. And then to finish the circle, you're going to go 3 in all the major directions. So you'll go 3 up, 3 down, 3 left, 3 right. So 3 up, 3 down, 3 left, 3 right. What do I have to be careful of when I'm connecting these points to form my circle? What did we have to consider with the other 3 graphs when we were drawing the line in?
Was it solid or dotted?
Solid or dotted, and was it going to be here?
Dotted.
Dotted. Okay, so draw that in. So we have to figure out, are we shading inside the circle or outside the circle? So we're going to test 0, 0. So we get 0 plus 1 squared plus 0 minus 2 squared is greater than 9. So this becomes 1 squared plus negative 2 squared is greater than 9. 1 squared is 1. Negative 2 squared is positive 4. So we end up with 5 is greater than 9, which is certainly not true. So where will we shade then? Outside, not where 0, 0 is. So outside of the circle. Okay. Any questions before we look at the last two? No? Okay, let's move to the next then. These two should hopefully look pretty familiar because you had them on your test. Okay. So for this one, we're going to make ourselves an XY chart. Plug in x values of -2, -1, 0, 1, and 2. If I plug in -2, I get 3 to the 0, which is 1. If I plug in -1, I get 3 to the first, which is 3. If I plug in 0, I get 3 squared, which is 9. 3 to the third, which is 27, and that one is going to be too big for me. I'm going to sneak one more point in. At the top, let's do a -3 also. If I plug in -3, my exponent will be -1, and 3 to the -1 is 1/3. So I'm going to graph these 4 points. So -3 to the 1/3 is about right there. -2, 1 is here. -1, 3. And 0, 9. Because of our equal sign, this is going to be a solid line. And hopefully you remember this graph has an asymptote. So this graph has an asymptote. It's going to be right here. So I do expect that asymptote drawn in. So we're going to plug in our test point then. Let's plug in 0, 0. We get 0 is greater than or equal to 3 to the 0 plus 2. So 0 is greater than or equal to 3 squared. 0 is greater than or equal to 9, which is false. So I do not want to shade where 0, 0 is then, which is right here. I don't want to shade there, so I shade on the other side. Bless you.
Thank you.
Okay, I need 5 more minutes of your time to do the last example. This should hopefully be quick theoretically if we remember what was on your test yesterday. When I'm going to graph a log, what is the first thing I should do?
Change base.
I agree with the change. I don't agree with the
Forms.
change forms.
Yeah, I just.
So this is base, argument, exponent. I get 2 to the y equals x. A lot of you changed forms on your test, but you had 2 x's in your equation. There should be a y. When I make my table, which number am I plugging in for, x or y?
Y.
Y is the exponent, so plug in for y.
Do we need to do -2, -1, 0, 1, 2 each time, or can we just do 3?
You can do 3. 5 is better, but you can't do 3.
Okay.
Okay, 2 to the negative second is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. Other issue, a lot of you came up with that table, but then didn't graph it right. So 1/4 comma -2 is about right here. 1/2 comma -1 is here. 1, 0. 2, 1. 4, 2. Notice there's no equal sign, so this is going to be a dashed line. And what I need us to remember is that this one has an asymptote as well. It's vertical though. So again, we need to plug in a test point. Can't be on the graph. Let's see what happens when we go to plug in 0, 0. We get 0 is less than log base 2 of 0.
Why can't we do it in the other equation?
Because that has switched forms.
Okay.
Yes. Yeah, so Christian asks, why can't we use this one? You can't, always has to go back to the original. Do you all remember talking about how this argument has to be greater than 0? Or does that now ring a bell? No. You can't do the log of 0. So I'm going to give you a secret. We're not going to test a point here. Instead, we are just going to read this inequality. This inequality says y is less than. Which way is less than, up or down? Down. Less than, below the graph. Less than is below the graph. So for logs only, don't test a point. Just read the inequality. Less than will be below the graph, greater than will be above the graph. Before we do the day 8 notes, there's one thing I want to make sure that we understand, and it's the meaning of this graph. This is something I should have said at the very beginning, but I didn't. What the meaning of this graph is this shading contains all of the points that satisfy this inequality. So any point in the shading satisfies the inequality. What the dashed line means is that points on that line don't satisfy the inequality. If it were solid, they would. But that's what our shading represents. The shading contains all the points that do satisfy the inequality.